Okay, so I have solved lots of problems. They were like pretty standard. So let's go through them. So problem one, create grid with exactly one path. So we are given to dimension m and n. We have to create an m cross n grid such that there's only one way to go from the top left point from the bot to the bottom right point. Like if we are only allowed to go right or down, so we can only go right or down, and we have to create a path in this. Uh, like we can walk through the free cell, and obviously we cannot walk through the obstacle. So the idea here is that, like, if we have a path like this, so this is like a constructive problem where we have to give any valid answer. So just simply choose one. Like this is the start point. So either choose this or choose this. Like this is like the simplest idea. Uh, so you can cover everything here and just give one path for movement like this. So that's what I've done mostly. So I created the answer for I equal to 0. Like for the first row, I created all dot, I mean all free path. Otherwise, obstacle dot repeat n minus 1. So this will like fill, it's got a little messy, but okay. So it will like fill hash here n minus 1 times. Like this dimension is n, this dimension is m. So here it will fill n minus 1 times hash, then one dot here. So yeah, this is the idea for problem 1. Problem 2. Okay, so here we are given some lights. So like it is like we have an array like this, and let's say if here it has a let's say 2 here, so twice or two positions left and two positions right, it is covering all these segments, all these positions. And then uh, and if anything is 0, then it is not covering anything. So we have to tell uh, like the number of extra bulbs we have to add such that the entire array is like highlighted, like illuminated in this case. So we have to add elements, and we can add only one. Like if we can only add one, so this gets covered, something like this. So we can use difference array for this. So let's take this example. If we have something like one here and two here, and others are 0. So what we can do to cover this one, like if you, so a final scenario would be like this is like the number of lights that cover this index. So it will be 0 1 1 2 1 1, because this position is covered by both 1 and like both 1 and 2. So yeah, it should be like this and this. Yeah, I mean this is the border, so it cannot go further, but yeah. So if we see, so the way to implement this efficiently is we create a difference array. So if 1 is present here and we want to highlight this part, uh, like if we want to highlight this part, so we'll do +1 here and -1 here. Similarly, for 2, like we have to highlight from here to here, let's say. So we will do +2 here and -2 here after the range. So what will happen is if you take the prefix sum of this array, this will give you this value, this array, like the highlighted one. So yeah, this is the first idea, that we take the prefix sum, like I take this prefix array, and if light of I is 0, then I minus lights of I, basically I do +1 there, and I plus lights of I +1, I do -1 there. So I actually missed this +1, that's why I got a penalty also. I could have missed that, but yeah. So and then -1 and take the prefix sum. So now this prefix array is equal to this array I have. Then I see the number of consecutive segments of zeros we have here. Here we only have 1 0. So we will just need one light bulb to help this. But like if we let's say if we have multiple zeros, and let's say 1 1 was the scenario. So let's do this. 1 1 was the scenario, and here I have multiple zeros. So one light bulb can illuminate three positions as given here. So it go from j minus 1 to j plus 1 at index j. So here I have four consecutive zeros. Let's do one more. Let's say our light bulb 1 was initially present. So this is the scenario. So four are here and one is here. So for illuminating these four, I need at least two bulbs here and I need one bulb here. So I maintain the count of consecutive zeros currently, and like if it is like, and then I iterate over the array basically. If it is 0, then we increase the count. Otherwise we increase the answer. Like this is like the consecutive number of zeros we have. So this is seed of count by 3, the number of bulbs we require for the segment. We add it to our answer and set the count to 0 again. So yeah, that is the idea for second problem. Third was also a very simple implementation problem. So we are given a tree and an array base time. So we have to like do a like tell the finish time of the root one, and this is like the definition to find the finish time for each node. So like this is a simulation idea only. Like you do DFS, and for a single when you're doing DFS of a single node you maintain the minimum and maximum finish time of all its children, like not even the subtree, like only the children, and then just put this formula and get the value. So that's what I've done here. If you see, this is like my tree template I generally use. But yeah, I created an answer array here, and yeah, in the DFS, I passed the base time array as the reference. I stored the min and max as the earliest and latest values, and after going like v is the child of u. So after going doing DFS over v, we have already calculated our answer of v. So we chose we update the minimum and maximum over v, and then accordingly, like if min is not updated, that means the leaf node. So this is like it will be just assign the base time as mentioned here. Otherwise we'll just put the formula which is mentioned here. It's, like if you know DFS on simple DFS on tree, like this is not a very difficult problem. So yeah, this is the third problem. Fourth one. Okay, so here we are given a range L to R and an integer k. We have to tell the number of good integers from L to R, and good integer like is every integer in which the absolute difference between every adjacent pair of digits is at most k. So if like k is 2, I can have 1, 3, 5, 7, 6, 8 or something like that. So the difference here is like at max 2. Like I can also have 1, 2, 3, 4, 5, that's also fine. So this, but I cannot have 1, 4, 3. This will not work. So this is like like the if you see the L and R are 10 power 15, so we cannot iterate over them. So this is like a standard digit TP idea. So we basically do is if we have to find the number of elements from L to R. So what I do, I find the number of elements from 0 to R. I find it from 0 to L minus 1 and I subtract it. So that's the first thing. I solve it I solve it for R, I solve it for L minus 1 and get the difference. Now how to solve it for a single integer? So here in I'll store dp of I, like the current digit I'm on. So we go in digit dp, right? So we go digit by digit. So I is the current digit I'm on, index of that. And if you see, like I have converted my integer to a string. So instead of having 1, 2, 3, it will be like string of 1, 2, 3. So I can get over each character. So I use a byte array. That's fine. So yeah, dp of I, the previous digit I've had, because I want to compare like the absolute difference, the tighter bound and leading zeros. So this is like a digit dp idea. If you know digit dp, then you'll know why you use tighter bound here. And we require leading zeros also because like if previous is 0 and we have not considered any number, then we have to with this flag is also required. So yeah, I initialize the array with -1 and then I solve it like simple DP and DP idea. So yeah, I mean nothing much to actually discuss here, just that if when I'm iterating over the current digit from 0 from in the range of digits I can choose, I just check if leading zeros is not 1, that means we have started the number, and the absolute difference between previous digit and the current digit should be less than equal to k. If it is greater than k, then we are not considering it. So yeah, that is like the idea. So yeah, this is also simple digit TP idea. So yeah, that's it from my side. Thanks for watching. Bye.